let's start our recording. We are in week 12. We'll be working with the project that is posted on Blackboard in week 11. That's our platformer game. The platformer should be in quotation marks, right? There's a few elements from the platformer, but that's what we do, right? We don't build a full game here, right? We are building just few elements that you can reuse later on in your project. So you should download this. What we have there, we have our character, right, with some animations, right? So we can move, right? We can jump. We can open the door. We have the enemy that is smart enough not to die right away, right? To fall and die. That's where we are right now. What we want to do today, we want to add ability to the player to shoot projectiles, and we'll use sorry, we will use some clouds from the package that we have here to do it, right? So he will be creating the cloud bullet. We'll also make both enemy and the player destructible, meaning that there will be health and there will be uniform interface allowing objects to interact and cause damage to the other side, right? And you will see that this way you can create objects that are quite flexible in the sense that you can control based on health and the damage that they have assigned what happens between them, right? So that's another thing that we want to do. And we will also add a little bit more in terms of animations to our player. So just to remind ourselves how to do it, right, step by step. Let's start with projectiles. As I said, I will use this. I will use this cloud. I didn't want to open it. I will use this cloud as my projectile. And since I'm using physics, cloud will need two things: collider and rigid body. Right, so we'll add rigid body to the, and we'll add collider, and I will use polygon collider. Okay. I will also have a script. Let's close this. Let's go to script. I will have a script, one assigned to the player that is shooting those projectiles. And the script will be called projectile shoot. And this is going to the player. Where is the player? Player is here. To the player. And I will have another script, projectile script. And this script will be assigned to the cloud. Okay. I will save this whole thing as a prefab. Let's call it projectile. And let's save it as a prefab. And we'll start editing those scripts. Just making sure that we are using mono. Okay. Let's change the font. Okay, so we are starting from the projectile shoot. That's the script that will create the projectile. This is assigned to the player. Player will react to some keys from the keyboard and will produce the projectile. This is also the script that will trigger the animation that we'll create in a second. So what do we need? What do we need in this file? We need a few things that we'll edit from Unity. First of all, we need to know what is the object that we'll use for the projectile, right? So game object projectile. Second of all, we need to know how hard we are throwing it. So the serialized field will be float projectile force. We'll set it to 500 to start with, and then we'll play with the number. You will see what happens. I said that we'll be also using animation. So we need animator. We'll be also pushing the projectile, so we'll need a rigid body, but that's something that we can set later on. It will be used only locally. And we need a transform. That's the objects transform, right? The players transform. We'll start with setting up animator in the start function. Game object get component animator, and setting up the transform the same way, right? Game object dot transform. Now we have to decide what will be our button that we use or a key that we use to fire the bullet, right? To fire the projectile. Input dot get key down code. With previous classes, I've been using Alt. It can be something else, right? It can be F, for example. F like fire, so we can remember it. Now what will happen here? Two things will happen. First of all, animator dot set trigger will trigger animation. That's part that we'll complete in a second, right? We'll add a new animation to our project, and we'll add new parameter to the animator so we can trigger this this animation. Second thing, we need to actually create the object and make it fly, right? And that will be something that we'll use, that we'll create a function for, right? So we'll have a fire projectile function that we'll call here. This function void fire projectile. We'll do a few things. First, it will instantiate the actual projectile, right? So game object equals instantiate. Instantiate has a few versions, 10 versions in total. If you look at the at the specification, but the basic three that that we've been using so far is the one that takes only a game object. you can provide transform, or you can provide position and rotation. All right. What we'll do today, we'll use the game object. So we'll get a projectile. That's our template. We'll provide the transform, the position of our player. That's where the bullet should show up in the beginning. And the last parameter, if you want to do that, is rotation. And we don't want to rotate our projectile. So we'll use Quaternion identity as the third parameter. So we are not rotating. Now, because we are pushing this object, we are not using transform, so it won't really use update to move, but it will use force that we will give in the beginning. We need rigid body. Right? Rigid body to D, RB is equal to P dot get component rigid body to D. Right, now what we need to do, we need to push this object, right? So RB dot add force. How much force? Well, how much is defined by projectile force? But that's just a number. That's just the length of the vector, right? Now we have to also decide about the direction. And direction will depend on the direction that the player is facing, right? So we'll take transform dot right, put the minus, because we want our player by default is facing left. Right? That's why minus is here. Then we have to multiply that by projectile force to set the proper length, and make sure that when we are flipping, it still works and flies in the proper direction. We need to take transform dot local scale dot x, because that's how we flip our player. Right? We are changing the local scale between 1 and -1. Right? So this number will be used here to make sure that the force is applied in the proper direction, and P dot transform dot local scale, we have to apply the same trick to the projectile itself, so it's not flying backwards. All right, so transform dot local scale. We have one thing done. We can produce the projectile. If we switch to Unity right now, we don't need this. We didn't assign the prefab, right? So that's what I have to do right now. That's my projectile. Right? Because of the kill zone, it hits me again. But you notice that it is not flying too far, right? It's just kind of falling instead of flying away. What does it mean? It means that our force that we set here to 500 is not enough. Right? What we can do, we can make it more, right? Make it stronger. It will fly the way we want, right? Another thing that you might have noticed is that firing kind of pulls me with the projectile, right? The projectile is pulling me with it, right? I'm not pressing any arrows, and yet my character is moving. That's because we have a collision with between the projectile and the character, right? So what we have to do, we have to make sure that this doesn't happen, right? And what we can do two things. We can either move the spawn point to be in front of the player, right? So the position that we pass here is not exactly the position of the player, but it's somewhere in front of him. One option. The other option is tell physics engine not to care about this collision. Ignore it. Right? And that's what we're going to do. We're going to say physics 2D, ignore collision. There are two parameters that we have to pass, and both of them are colliders. Right? The collider from object A and object B, that will be ignored in the processing. Right? So we have game object, get component, collider B. That's the collider from the player, and P dot get component collider to the collider from projectile. If we test this, we don't have the drag, right? It's not moving anymore. Hey, let's add animation. We have a player. Sorry. We have those animations here, right? Let's add animation that will be played when we are throwing this cloud. Okay? In our hero pack, we have this animation called, which one was it? Attack. And the guy's just kind of waving the arm. So we'll use this as our animation. So let's start with creating the clip. And the fastest way to do it, I told you, right, is to do this. Add it to the scene. It creates the clip and creates additional controller. You don't need this anymore. Now let's go to the animator. Let's add new state. The state will be called fire. It will be associated, so the motion is this animation that we created, fire animation. I told you that we'll have a trigger called fire. And we want to play fire animation without really caring about in which state we are, right? So if we are in idle or jump or run, in any of those states, we want to be able to play fire. So instead of doing 3 transitions, I will make one from any state. Right? And this transition has no exit time because we don't know how other transitions will do. Conditions, one condition when fire is set, we want to make transition to here. I cannot simply make transition back to any state because it doesn't make sense, right? Going back to any state meaning where, right? What I will do instead, I will make transition to idle. Idle, if you remember, idle is very short animation, but it's connected with everything else, right? So it's a perfect place to make this decision. When do we make a transition? When fire is finished, right? So we have has exit time set. Let's test. I'm standing here, pressing fire, and it looks very weird, right? Because it flows first, and then you have him waving. What we can do? Well, we can play with the code. That won't give us much. Instead, we'll move the place where we fire the projectile. Instead of having it in the code, we'll fire the projectile from animation. Remember the idea that we used in the side scroller with the explosion? Explosion was added, the animation was added as a separate game object. And when it was finished, it was destroying itself, right? And we used animation event, right? And that's what we're gonna do here. So I'm selecting my player, going to window and opening animation. Here it is. I have to select the animation that I want, right? I have all of them on the list. I'm interested in fire. And what I want to do, I want to add event somewhere in the middle, right? Not exactly at the end, but somewhere where the hand is kind of like here, right? So 1, 2, 3, 4 steps from the end. What is the event? Event is firing our function, right? Fire projectile. Let's test. Did I remove it from here? I did, but I didn't save the file. Okay, Control S. Okay, here we are, waving. Better? A little, right? Okay. What happens with our projectiles? Well, they're flying and then falling, and then nothing happens with them. And you can see it here, right? If I fire here, they're just staying. Not exactly what you would expect from the projectile, right? So what we have to do, we have to open the projectile script and do some work in here as well. So first of all, I know that I don't want to have those projectiles flying forever, right? Because if I start shooting more and more and more, I will have too many objects in the scene. They should disappear after some time, automatically. And we'll do that with the coroutine. Right, so we'll have function finish, but we'll do one simple thing. We'll wait. Let's say we'll wait 1 second, and then we'll destroy game object. And then we'll start this immediately, right? Start coroutine. This way, when we fire, let's see. I have those projectiles disappearing, right? So that's one thing. And it doesn't resolve the situation when you throw it at something and it stays there, right? So that's another thing that we have to do. We have to react to collisions, right? So we'll have void on collision, enter. 2D. Collision 2D is a parameter. And we need to have a handler for collisions. And now it's a good place to introduce the idea with the damageable interface. So what I want to have, I want to treat all objects in my game that can be destroyed in a uniform way. So what I will do, I will add a public interface one simple function. One simple function. The object that will implement this interface will have health and will be affected, the health will be affected by calling this function, right? If I shoot the projectile as a player and the projectile hits the enemy or anything else, let's say enemy, and my projectile is causing, let's say, damage of 10, and my enemy has health of 5, it will be destroyed, right? But if it has a health of 50, the health will decrease, right? So that's the idea. But because I have this interface, I will be able to treat all objects in the same way, right? So now in collisions, what I will do, instead of getting a tag and checking what is the object and thinking about how to work with that, I will simply take instance of the script that is implementing iDamageable, other game object, get component, iDamageable, and I will call function damage. But I will call this function only if B is not null. If B is null, it means that the object that I'm hitting is not really damageable, right? So let's say platforms will be like that. You can shoot and into the platform, but platforms won't disappear, right? Or you may have a situation in your game when some of them do, right? So we are doing that, and we are calling damage as a function. Now, how much of the damage? We'll have parameter. Say 10 for now. Have a parameter, and we'll be able to set this from Unity, right? So we will be able to reuse this script and set different values for damage, and automatically you have different weapons. After doing that, we are ready to destroy game object. So this case, it makes the bullet itself to disappear after collision, right? And it will disappear no matter what is hit. If it's damageable or not, it has to disappear in both cases, right? Control S. Let's see now. It's working, right? The bullets are disappearing, but our enemy is not ready yet. And we have to modify the enemy script. Enemy controller. Let's make this guy damageable. I'm adding interface to the class declaration, scrolling down and adding two things. Health. Let's say my enemy for now will have 10 points of health, and public void image. If first health minus equal D, right? So we are decreasing the health based on the damage that was caused by this function. And if health is less equal 0, means that the enemy is defeated, right? Destroy game object. Now we have enemy that can be killed. One shot. If I want my enemy to be more resistant, I can change the value of health. Right? I can add more health to the enemy. What is the value for my prefab? It's 10.
Or maybe there's a typo. Instead of health, one of them you have written height.
Oh, you're right. Thank you. I missed that. Skilled. We make him more resistant. Get you. Fun, right? 5 interactions. And you can play with both, right? Because you have this prefab here, right? And you can change damage. You can use multiple versions of your weapon with different damage that they can make. You can use the same idea creating traps. Because not only your enemy can be damageable or destructible, but also your player, right? You can have exactly the same approach. Go to the code with the player. So let's find player controller, right? We can make this player damageable and add health. Right, int health, say 100, and then void damage. Right? Very similar code that we'll have here. Right, if health test equals 0, then we have to do something. What we'll do with the player? For the player, probably we won't destroy the object, but instead we'll play animation, right? So we'll have some bug that is saying that we are dead. False in the beginning. Right? Later on, we'll set it to true. And then in animator, we'll set a boolean that will make us dead. We'll play the dead animation, right? Now, when you're dead, you're usually not interacting with other elements, with other objects. You can do two things, right? You can get the game object, right? And you can set active false. That's one option that you have, and it will stop interacting with other objects. You want to have some funny behaviors. What you can do this. If not dead, then you respond to stuff. Otherwise, you're just lying flat, but enemies will be still able to push you, right? So you will see the nasty snowman disposing the body. Okay. We have this. I saved this. What is the error? I probably made a spelling error. Now it's okay. Right? The function has to be public. Hey, we can go to one more thing. So if our player is right now damageable, let's use this. Right? Let's go back to our enemy and let's make sure that if enemy collides with the player, and the player gets hit, right? So void on collision enter 2D, collision 2D, other if other dot actually hold on. We have to take the damageable, right? So I damageable D equals other dot game object get component I damageable. And if D is not null, then D dot damage. How much damage? Let's say 1/3 of the life. The player has 100, let's say 30. will be the strength of the enemy. If we leave it like that, your enemy will be also able to destroy other things, right? So if there is another enemy that is destructible or destroyable, they will be fighting. If you don't want to have that, what you can do, you can add another condition, right? That the enemy is only fighting with the player, right? So, and other dot game object dot tag dot equals player, right? Can do that. Also, we have to make sure that the player itself has a tag and it doesn't have, right? So let's make sure that it has a tag player. Okay, now we can test. You're dead. Our health is 0, or minus 20 in this case. But we don't have animation, right? So that's why I'm stuck in this weird pose. You see that the nasty guy is pushing me, wants to dispose this poor hero. Bye-bye, hero. I'll be back. Okay. So animation, right? Animation. We have animation where the hero is dying. Let's use it. Come on. Here it is. Bye. Let's go to the animator. Let's add new state. Well, first let's add new parameter. Dead. Now let's add new state. Dead. Motion. This clip that we created, die. And the transition again from any state, this dying state, based on the dead parameter. We don't have any outgoing transition, because dead in this case is terminal state for our player, right? Okay, so we can test. I know where the snowman is carrying my hero, but must be somewhere. Okay, so you have basics. Just a reminder, in your project, you need to change the scenes, right? You will have multiple levels. Do you remember how to change the scene? Okay, to change the scene, you have to do two things, right? First, there is a class called Scene Manager, and you have it in using Scene Management. That's the package that you have to add. And then you have a class. You have a class Scene Manager. And you can load scene. This function takes either a string, that is the name of the scene, or it can take a number, which is the index of your scene. Now, for this function to work, what you have to do, you have to go to build settings, and you have to make sure that all the scenes that you plan to use in your final version for transitions are listed here. And you can drag and drop, or you can add scenes this way, right? This is the name that you can use. This is the index, right? That's a reminder because we've been doing that. We've been practicing that in one of the labs. But I want you to remember that the configuration part is also important, right? Because if your scenes are not in the build settings, if they're not added to this list, you will get a runtime exception when you try to make a transition, right? That may be confusing. Remember to include that. Okay, what I will do right now, I will stop the recording, and we'll start answering your questions if